Okay guys, so today we will talk about embedded operating system. We'll discuss the definition of embedded operating system. Then we will discuss the applications of embedded operating system, which is also known as RTOS, real-time operating system. We'll discuss what's basically the role of embedded operating system in security field, why it is important to learn in ethical hacking. We'll talk about it. And then we will also discuss some common pitfalls, vulnerabilities of embedded operating systems. So these are the three main agenda items that we are going to discuss today. First of all, the definition of embedded operating system. So any system which is designed to perform specific tasks, not the general purpose task, is called the embedded operating system. Or you can say embedded system is basically system on chip. System on chip. SoC. For example, it could be your car ignition system chip. It could be microprocessor. Any kind of small chip which is basically a part of a big computer is called embedded system. Okay. In order to use embedded system, we use, or in order to run a hardware, please remember one thing. If you want to run a hardware, you need operating system. Like hardware is kind of a body, and operating system is basically the soul of that hardware. So embedded system, they use a specific kind of operating system, which is called, embedded system uses RTOS, which is known as real-time operating system. These real-time operating systems, or you can say RTOS or embedded operating systems, they just like the normal operating system, or you can say just like the other operating system, for example, Windows, Linux. We do have some the copyrighted operating systems where you have to purchase the license and all that stuff for your sensors or for your small gadgets, small devices. And we do have some open source, just like Linux operating systems as well. First of all, Microsoft, they do have they do actually make embedded operating system. One of their most widely used operating system is called Windows 10 IoTs. Windows 10 Internet of Things. So Windows 10 IoT, it's not basically for the individual. Like for example, if you are a manufacturer of chip, or for example sensor or stuff like that, then you can actually purchase this corporate solution. Windows IoT, it's just like it has the same features as of the Windows 10, but it doesn't offer you a GUI. Like there is no desktop. Like because in the sensors, of course, you don't need a GUI, in fact, because everything is like on the command line. It works on that. So Windows 10, it offers full Windows APIs, full Windows API besides the desktop environment, or you can say without the desktop feature. And usually it's very common in the corporate world because there are a lot of support, a lot of other stuff as well. One of the Windows operating system, which is whose source code is publicly available, it is called Windows CE. Again, that's for the sensors. Windows CE is basically Microsoft. They made the source code available to public, and it's kind of basically the trimmed version of Windows Desktop. In fact, like it's the trimmed version of Windows XP, but it's specifically designed for the IoTs or embedded systems, like for the small chips. So Windows CE, the source code is available to public. So please remember that it's important from quiz point of view as well. It's public, and it's the trimmed version of Windows Desktop operating system. So it's the trimmed version of Windows Desktop operating system. Other than that, for the access control stuff for these embedded operating systems, just like the other the Windows 10 or Windows 8, Windows 7, they use a filing system. One of the filing system that you might heard about, it's FAT. It's the filing system, which is, of course, we don't use that filing system anymore in Microsoft Windows because there are some shortcomings. FAT, first of all, it stands for File allocation table. So this was a filing system to access, to control the access of the files, or you can say the data, for between the users, or for example, if there would be a sensor, like within the sensor, of course, if you have operating system, you must have a filing system as well to control over the data, like who can access this file, who cannot access the file. So file access table, allocation table, it used to be one of the file accessing method, but nowadays it's being obsolete because it doesn't support ACL, access control list. No ACL support. There was no access control list support for FAT. Nowadays, what we use is NTFS, New Technology Filing System. This is what we use in Microsoft, including the Windows 10 IoT and including your Windows 10 desktop operating system even. So New Technology File System, that's basically what we currently use. So this is currently in use. On the other side, embedded Linux, like embedded operating system, embedded Linux operating system, in fact, there are many variants. For example, excuse me, there are many variants, like for example, the Cisco devices, like for example, Cisco routers and all that, they use QNX software. Again, just like the Windows 10 IoT, it's basically empowered the Cisco devices. For example, Cisco routers, switches, firewalls, they use QNX software. Like some of the devices like printers, they actually use, for example, if you have a printer, it does have operating system, and printer actually use, most of the printers, they use Green Hill software. There are many examples like that. The embedded operating system, like which is freely available for public, it's basically the monolithic operating system. Okay, and again the form is green. VxWare is basically one of the variants for that. So monolithic operating system, it's basically the what we use with most of the ISM product. ISM band products are basically routers, switches, and all that. Okay, they actually use this monolithic operating system. Again, absolutely free. Source code is available, so it can be customized. So you can customize it. It can be customized just like others. But there is one biggest issue with these embedded Linux operating system, and that problem is Rootkit. So there is a Rootkit which is very common, and that's called Linux Rootkit 5. So Linux Rootkit 5 is the biggest problem, biggest issue, and that comes with the embedded Linux operating system. You really have to take care of Linux Root 5 if you want to use embedded Linux operating system. For access control in the embedded Linux operating system, they use mandatory access control. Mandatory access control. And as you know, it's the most restricted model. We can control over it. Let me write down the definition for your quiz, or if you need to remember that. is an Linux operating system mechanism, the access control mechanism, in fact, that enforces access rules based on privileges for interactions between processes and users and files, in fact. Just like in other operating system, for other Linux operating system, if you wanna update the packages, again they use the same package like apt package. So just like other Ubuntu and Debian and others, so in order to update the package, we use the command apt get. So that's the command we use in order to update the package. It's exactly the same way how you will update the firmware of your embedded Linux operating system. Some of the common vulnerabilities. One of the vulnerabilities is same like card skimmers, like card skimmers. You can say to steal the credential. It is again very common. One of the biggest vulnerability with these embedded operating system, which is really a big issue as well, and that's called the null SA password. SA stands for system admin, and that's the biggest problem. Like what happens if you have if you use the SQL server. In fact, if you use SQL server, most of the system admin password or account, there is no password for that. Like there is no password. You need to know the system admin name, and you can directly access the database. That's the biggest problem, and because of this, or you can simply say it's the most critical SQL injection vulnerability, because through that your password can be hacked, or other issues can be, like people can in fact hack your database. That's the biggest issue with that. There are many other vulnerabilities, like rootkit is the biggest problem. Rootkits are one of the biggest problem of these embedded operating system, because what they do is they modify the operating system file, and whenever this the chip, or you can say the device, it reboot this rootkit, these rootkits, they also gets the triggered in fact. Embedded operating system in network, we use these embedded operating system a lot. Like we use embedded operating system in routers, in switches, everywhere. Even in our access point at home, we use these embedded operating systems. So, and again, we don't know. Like, I mean, most of the people that think they don't have operating system. But again, please remember, if you have a hardware, it cannot run without having an operating system. And the operating system that we use to run these kind of devices is known as embedded operating system. Embedded operating system, like we do have the network operating system for control for managing these embedded operating systems or devices. So having a network-based embedded operating system, we can do better manageability and control. For example, again, the thing is, in order to access those, for example, let's say, let me explain you. For example, this is your embedded, this is a server, in fact, and we are running embedded network operating system on it to control over sensors. Sensors are deployed in this particular field. For example, sensor is here, one sensor is here, one is here, one is here, and one is here. All these sensors are basically responding to our network or the server, maybe from apart. Now the thing is, or you can say the problem is, like if you want to access this particular server, we cannot directly control over it. So we need to create a WAN, wide area network. Like all these sensors should be connected with internet. So they should have a connection to internet, and then they can respond to a network. So of course, internet is required. And whenever we use internet, we need to actually open some ports of these, devices as well. So some of the ports need to be open in order to respond, in order to communicate with the server. And that's basically where the problem is. Like for example, if the port FTP, like for example, if it is a web server, if web server port is open, like in the embedded operating system, it can cause potential vulnerability to an attack. For example, if a hacker takes control of your router, so they can access any device over the network. So in order to control over it, we actually use again the filing systems. Okay, again from the network side, like one of the filing system is CAFS, Common Internet File System. This is one of the filing system. So common internet filing system, there are different levels in common internet filing system, like user level, security level, server level, and all that. So for example, I mean, if you're using the user level security model with CAFS to access these devices, so what can happen? It requires network users to have a username and password to access specific resource. So for example, if anybody wants to access this server, they need to put a password here. But for example, if somebody is in the network, if they want to use, let's say, if there is a person, another person on the same network, for example, if he can access this particular sensor and you want him, because he's a legitimate user, you want him to access some other resources as well, then in this filing model, we need to put another level, which is known as share level security. Within this share level security, I mean, it doesn't require, like, user will be authenticated first, but after authentication, it doesn't require password to share a file or to access a file. Some other problems are these sensors are basically difficult to patch. Sometimes it is very hard to patch over these. Reason is that, like, these sensors could be in, millions maybe. So in order to update their firmware, it's gonna cost companies. Sometimes you need to actually find like what will be the fixing expenses. For example, if there is a sensor, the worth of that particular sensor is, let's say, $1. And in order to fix the vulnerability, you might need $3 to fix it. So, I mean, there's no point to fix the problem. Like, why don't we replace the whole sensor? That's basically sometimes you need to make it. Sometimes embedded operating systems, in order to update that, they have to continuously communicate with the server. That's another problem, because you cannot go on site in order to update that sensor. That's another problem. Sometimes these sensor environmental conditions may affect your updating and stuff like that. Another problem with these embedded systems are buffer overflow attack, which we already talked about. And buffer overflow attack usually affect applications which are basically designed on C and C++. So most of the applications which are designed on C and C++ are more vulnerable to the buffer overflow attack. Then, as I already talked about, the networking devices, for example, if anybody has control over your router. So for example, if your router gets compromised, then attackers can access control of the network. Like, they can access any device in your network if they can take control of the router. That's the problem. Some other devices in your network, for example, fax machine, printers, they also use the embedded operating system. So sometimes there are few devices which perform multiple functionalities, like MFD, multi-function device, They also use the same operating system, embedded operating system. They can do, they perform multiple functions. For example, a machine is basically printing, scanning, for example, a fax machine as well. So if you have a machine which can perform multiple functionalities, it is called MFD. Again, it uses the embedded operating system. And again, if anybody controls over the operating system, they can control that machine. For remote accessing of the devices or the sensors, SCADA system is basically the solution. Supervisory control of data acquisition. Supervisory control and data acquisition. That's basically what SCADA systems do. SCADA systems are basically used to monitor devices or control the equipment remotely. Okay. Um, Again, the thing is, there could be a problem sometime. Like for example, this is basically your, SCADA system which is deployed here, and we are controlling specific equipment, okay, by using this. And these sensors are connected with internet, okay. And now this is a person, authenticated person. He can control this machine by using internet, give the signals through internet to these sensors or these devices, and they can control over the machine. That's how SCADA system look like. But now the problem is, if anybody outsider hack these devices or system, and then he or she can control over the device. That's a problem. In order to avoid this problem, we use a technology called air gap. And what this air gap does, it separates the SCADA system infrastructure from internet. And how it does it? So with the air gap is basically just like your firewall. Okay, only legitimate people they can actually go through, otherwise not. The last thing is cell phones. As you already familiar with the different problem of cell phone, like sniffing is the biggest issue of cell phone. People can use keystroke loggers and control the devices. But there are many viruses which are designed for cell phone applications. For example, if you have a smartphone running Android, Windows, or iOS, they can be affected by those viruses. And mostly Java-based viruses have been created by attackers. And they can actually infect your Android phone, no matter if you have Android phone, if you have a Windows phone, or if you have an iOS. So all these operating system devices can be affected because most of the applications are basically based on Java, and that's why the viruses, they are also designed on Java. We already talked about rootkits. Rootkits, as you know, they can, if there is a rootkit in your computer or in your device or in your embedded device even, it is impossible to remove the rootkits. Of course, we need to actually update the firmware. But the biggest problem of the rootkit is they can actually affect your firmware. If somebody or a virus can affect your firm software, then of course it will be really hard to get that device fixed. So rootkits, usually what they do is they infect, most of the rootkits in fact, what they do, they infect the firmware part of the devices. So such rootkit is really dangerous, and that's the biggest threat if they affect your firmware. Some of the other rootkits are basically BIOS, basic input output based rootkits, and can be installed in a system's flash memory to allow an attacker to access a system even at a later date. So that's it about this chapter. If anybody has any questions, please do let me know. Thank you.